Hey guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome each and every one of us to my discussion for today. And I'm going to look at the concept of the Hobbit's rule in an indeterminate form of this specific function. And of course, I'm going to be basically relying on this specific form, which is going to be 0 over 0 given as such. Now, in our previous discussion, I had basically mentioned that we have a variety of methods which we are going to use in trying to solve limits of various functions, which we can list perhaps in terms of a substitution method, which we have used in some of our examples. And of course, we're going to see that we're going to have a factoring method as another way of finding limits of some, functions. And we're also going to see that we can use the conjugate method among others in trying to solve limits of some of the functions which we're going to come across. Now, in case these methods are not going to be proving useful in some of the functions, we're going to see that some of the functions are going to be having results of the form of 0 over 0, like the one which I've just had on the board, or the one which is going to be our subject of a discussion in this particular case. And we're also going to see that in some of the cases, we're going to have results which are going to be a positive infinity over positive infinity given as such. And in some cases, we're going to have results which are going to be in the form of 0 times a positive or negative infinity given as such. And in some cases, we're going to have a range of results which are going to be negative infinity minus negative infinity. And in some cases, 1 raised to infinity, 0 raised to 0. Perhaps we are going also to have just a range of values which are going to produce these specific results. And we said that these are going to constitute what we refer to as indeterminate forms. And we have defined this specific concept of indeterminate forms, which are going to be particularly providing for us no clue of what these specific concepts are going to be entailing. And therefore, as we said, one individual by the name Lihobito came up with or devised a way of finding these specific limits of indeterminate form of functions. And this, of course, is going to be given in the form of what we refer to as Lihobito's rule. Now, in our last discussion, basically, I had just given an elaboration on this specific form of Lihobito's rule, which basically gives a format for us in trying to find these specific limits, which are going to consist of a result of indeterminate, of course, forms, just like the ones which I've listed on the board. So in summary form, I'm just going to quote this specific rule, which gives that if we have the limit of a function given as fx all over another function which is going to be g of x, these are going to constitute polynomials. This limit can be given in terms of the limit as x tends to c of the first derivative of this specific function for the polynomial of x and of course g. And this is going to be giving us in a way a summary of what constitutes the L'Hopital's rule. Now, in a sense, we're going to see that this basically are going to be the respective derivatives of these two specific functions. And therefore, we're going to test the two methods, perhaps for substitution and L'Hopital's rule, and try to see what some of the results we're going to obtain from this specific evaluation. Now, in this case, I'm going to take this one given in this particular form. So I'm just going to reserve this one and this specific point so that in case we need to do a reference, then it's going to be okay for us. So in this particular case, I'm going to use the first method of substitution. I'm trying to find basically what this specific limit for this one is. And in this case, I'm going to take this particular value of x as it tends to 0 and substitute it in this particular value of x, of course, e raised to power 0 minus. In this case, we're going to see that for us to have this specific substitution, we're going to maintain these particular values, and the value of x is going to be giving us 0. So in this case, a number raised to 0 is equivalent to 1. So this implies that 1 minus 1 over 0, which is basically going to be giving us results of this form, which we said are indeterminate forms of the results giving us 0 over 0. So in this case, we're not going to be having information on what this basic basically what these limits entail. And therefore, the L'Hopital's rule is going to be coming handy for us to understand what basically this rule constitutes. And therefore, we're going to take the first derivative of this specific function, whereby we are going to see that according to L'Hopital's rule, we can have this specific function given in this particular form, whereby we're going to have the limit of this function as x tends to 0 over ax minus 1 all over x is equivalent to. So we're going to take the first derivative of this specific function as the limit of this particular value of x tends to 0, whereby we're going to have this one given in terms of ax, and then of course we're going to maintain this one. So the derivative of 1 is going to be retained just as or just going to be 0. Remember, if we have a value of just like 5 and we're trying to find a derivative for this one, if we have a variable x, this means that we're going to have x raised to power 0 as one of the coefficients, or just a coefficient of this specific function. So if we take this particular value to be a coefficient of 5, then therefore we're going to have this whole function given as a 0. So therefore the value of 1 is going to disappear, and we're going to have the derivative of this specific lower part given in terms of 1. So if we take this specific value, just like we had done for substitution for the value of x equivalent to, of course, 0, then we're going to have this limit written in terms of e raised to power 0 all over 1. So this is equivalent to 1 over 1, which is basically 1. And this is going to be giving us a clue on what basically this limit is going to entail according to the L'Hopital's rule, which is of course going to be, giving us further information unlike the indeterminate form which we have seen for a substitution method. So this is one of the strategies that we're going to use in trying to evaluate a range of conditions which are basically given for various results of indeterminate form. And for the first one, which we have seen for 0 over 0, of course, this is going to be an example which we can give as such. So kindly check out description boxes for various links of other videos. Engage us in the comment section and also ring that notification bell for an update on different discussion we do in math and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.